Hello viewers, in today's class we are going to discuss a very important topic from coordinate geometry, right? So here the topic is related to the parabola, and here we have to discuss the length of the chord intercepted by the parabola y square equal to 4ax on the line y is equal to mx plus c, right? So here this is our topic, and related to this topic we have a problem, that is find the length of the chord intercepted by the parabola y square equal to 4x on the line 2x plus y is equal to 3, right? And this is a very important topic, and let us discuss it. So now viewers, here what we have the coordinate axis. This is x-axis and this is y-axis, and here we have a parabola, right? And this is the rough sketch, and this is the parabola y square is equal to 4ax, right? Now what we have to do, we have to find the length of the chord which is intercepted by the parabola on the line y is equal to mx plus c, right? Now suppose we have the line like this, right? So this is the line y is equal to mx plus c, right? So what we have here, this is the parabola, and this is y square is equal to 4ax, and this is our line y is equal to mx plus c, right? And here we see that this line intersects this parabola at these 2 points, right? So this is the first point. Let us say this point is A, and let us say this point is B, right? So now here this segment AB is the chord, right, whose length is to be determined, right? So here our topic is length of the chord intercepted by the parabola y square is equal to 4ax on the line y is equal to mx plus c. So this is the parabola and this is the line, and this line intersects this parabola at these 2 points A and B, and we have to find the length of this chord, right? So AB is the chord intercepted between this parabola and the line, right? So now what we will do here, we have to find the coordinates of the points A and B, right? So once we know the coordinates of point A and B, we can simply use the distance formula to find out the distance AB, right? So let us take the coordinates of this point A as x1, y1, right? And we can take the coordinates of point B as x2, y2, right? Okay, so now viewers, here we have two methods, right? So the first method is the detailed derivation of the formula which is to be used to find out the length of AB, right? And the second one is to directly use the formula to find out the length of this chord, right? So now here we'll discuss both the methods one by one, right? So when a parabola y square is equal to 4ax, it intersects this line y is equal to mx plus c, then the length of this chord AB, right? The length of this chord AB is given by the formula 4 over m square, and here we have square root of a square minus amc, and here we have 1 plus m square, right? So this is the direct result to find out the length of this chord AB, right? So here first we will find out the length of this chord AB with the help of this formula, right? So we'll apply this formula to this problem. So here we have the equation of parabola as y square is equal to 4x, right? And if we compare it with y square is equal to 4ax, then we see that the value of a is 1, right? And if we take this line 2x plus y is equal to 3, then we can write it as y is equal to minus 2x plus 3, right? And if we compare it with this line y is equal to mx plus c, then we have m is equal to minus 2 and c is equal to 3, right? So we have now a is equal to 1, m is equal to minus 2 and c is equal to 3. Now we can find out the length of this chord AB by using this result, right? So now AB is given by 4 over m square. M is the slope of the line, so m is minus 2, so we have minus 2 square, then we have square root of, here we have a square is 1 square, that is 1, minus amc, right? And the product of am and c is 1 times minus 2 times 3, that is minus 6. So here we have minus 6, right? And here we have 1 plus m square. So m square is minus 2 square, that is 4. And so this expression, it reads now minus 2 square is 4, and here we have 1 plus 6, and here we have 1 plus 4, 5. So 4 and 4 get cancelled, so we are left with 6 plus 1, 7 times 5, that is square root of 35, right? So if we have to solve this problem, find the length of the chord intercepted by the parabola y square equal to 4x on the line 2x plus 3 is equal to 2x plus y is equal to 3, then we can directly use this result, and the length of the chord is square root of 35, right? So this is the first method where we have used the direct result. We have to just use the values of a, m and c, right? So we can substitute these values in the given formula to get the length of the chord, right? So here we are not bothered about the coordinates of the points x1 y1, that is the point A, and B is x2 y2, right? So this is the direct application of this result, right? Now let us see the detailed method how to arrive at this result by actually finding out the coordinates. So now viewers, in order to find out the length of this chord AB, we have to find the coordinates A and B, right? So what we will do, we'll solve these two equations simultaneously. So now we have y square is equal to 4x, and from here we have y is equal to 3 minus 2x, right? Now taking this value of y in this equation, we have 3 minus 2x square is equal to 4x, and we have now 9 plus 4x square minus 12x is equal to 4x, and we have now 4x square minus 16x plus 9 is equal to 0, right? So solving these two equations simultaneously, we have this quadratic equation, right? And we know that every quadratic equation has two roots, right? So let us take the roots of these two equations as x1 and x2, right? So this is our x1 and this is our x2, right? So this quadratic equation has two roots, x1 and x2, and we have to find the values of y1 and y2 corresponding to x1 and x2, right? So now if we compare this equation with ax square plus bx plus c is equal to 0, then we see that a is 4, b is minus 16, and c is 9, right? Now from the theory of quadratic equations, we know that the sum of the roots, that is s, which is x1 plus x2, right? So the sum of the roots is equal to minus b over a, and the product of the roots, that is x1 x2, is equal to c over a, right? So now x1 plus x2 is equal to minus b over a, and b is minus 16 and a is 4, right? So now we have 4. So minus minus plus, 4 4 is 16. So now we have x1 plus x2 is equal to 4, and the product of the roots, that is x1 x2, is equal to c over a. C is 9 and a is 4, right? So the product of the roots is equal to 9 over 4. So now viewers, we know that the point of intersection of this parabola and this line are x1 y1 and x2 y2. So these 2 points A and B would satisfy the equations of the parabola and the line at the same time, right? So x1 y1 will satisfy this equation, that is y is equal to 3 minus 2x. So we can write y1 is equal to 3 minus 2x1, right? And similarly x2 y2 would also satisfy the equation of the line. So we can write again y2 is equal to 3 minus 2x2, right? So now we can subtract these two equations. So we have y2 minus y1 is equal to 3 minus 2x2 minus 3 plus 2x1. So this 3 and this 3 get cancelled, and we are left with minus 2 x2 minus x1, right? So now we have y2 minus y1 is equal to minus 2 x2 minus x1, right? So now the length of this chord AB can be given by the distance formula, and the distance between these 2 points, that is x1 y1 x2 y2, is given by x2 minus x1 square plus y2 minus y1 square, right? So AB square is x2 minus x1 square plus y2 minus y1 square, and from here y2 minus y1 is minus 2 x2 minus x1. So now AB square, it reads as x2 minus x1 square plus y2 minus y1 is this. So we have 4, minus square is plus, so 4, and here we have x2 minus x1 square, right? So now AB square can be written as here we have the coefficient 1, so this is 4, so 4 plus 1 is 5, right? And we have 5 x2 minus x1 square, right? Now here we have x1 plus x2 is equal to 4, and here we have x1 x2, sorry, it is x1 x2, right? So x1 plus x2 is 4 and x1 x2 is 9 over 4, right? So these two will be used to find out AB square, right? So now here we have to express this term x2 minus x1 square as x1 plus x2 square, and here we can take minus 4x1 x2, right? Because if we expand x1 plus x2 square, that is x1 square plus x2 square plus 2x1 x2, then 2x1 x2 minus 4x1 x2 is minus 2x1 x2, which is again x2 minus x1 whole square, right? So now here we have x1 plus x2 square is 4 square, and here we have 4 times x1 x2, which is 9 over 4, right? So here what we have done, we have used the identity, that is a minus b square is equal to a plus b square minus 4ab, right? So now 4 and 4 get cancelled, so we have 5, and 4 square is 16, and here we have 9, so we have 5 times 16 minus 9 is 7, so this is 35. 7 5s are 35. So therefore here AB square is equal to 35, so AB is square root of 35, right? And thus we see that the length of this chord AB is same which we have obtained earlier by making use of the direct formula, right? So viewers, this is how we solve this problem with the help of the direct result and by making the concept of quadratic equations, right?